Well, judging from the discussions on the course forum, in problem set 1, the questions that caused people the most difficulty were numbers 6 and 7. Those are those questions about Alice. And let's just see what's going on here. Notice that in each of these, we've got the same phrase: works in a bank, works in a bank, works in a bank, works in a bank, works in a bank. But for 4 of these, there's an additional requirement. Not only does she work in a bank, but something else, works in a bank, something else, works in a bank, something else, works in a bank, something else. Each of these additional requirements, each time you've got one, it makes it less likely to happen, because you've got something else to satisfy. They all have to satisfy the fact that Alice works in a bank, but for the first 4, Alice also has to satisfy something else. So each of these makes it less likely, it makes it less likely to be true. So this one is the one most likely to be true. Now, it's possible that in a particular instance, another one has the same likelihood. We're not saying that there's a unique most likely one, but we are saying there's a most likely one. Incidentally, it doesn't matter whether you express in terms of the word likely or the word probable or probability. You can do it numerically. You can do it however you want. The issue is not what the word is. The issue is the information you have. And in each of these cases, you have an extra restriction. And whenever you've got an extra restriction with a conjunction, and it's critical that there's conjunction here, when you've got an extra restriction with a conjunction, it makes it less likely. Because instead of just having to satisfy one thing, you have to satisfy 2 things. And when you satisfy 2 things, it makes it less likely to happen. So regardless of whether you use the word likely, probable, whatever you want to do, the most likely one is this one, because this is the easiest one to satisfy. And this actually, I think, is a great example of mathematical thinking. I mean, this is a superb example of the kind of thing I'm talking about in this course, because we're arguing purely in terms of mathematics. In fact, it's the mathematics of the word and. The reason this is in this problem set is because this is all about the way and works. So if you really understand how and works, this one just drops right out. That's why it's there. It's to make you really reflect on conjunction and the power of conjunction. Okay, so it's there you go. It's all to do with the amount of information you get. Incidentally, all that probability theory does, well, I say all, I mean probability theory is a powerful theory, but what probability theory does is adds numbers to the amount of information we have. Okay, and in this case, the extra information is more restrictive, and when you assign probabilities to that, that gets reflected. Okay, well, that was number 6. Let's take a look at number 7. Well, number 7 is slightly different because we don't have a common expression in all of the 5 in the case of works in a bank. In this one, we have works in a bank and something else. This one we've got is a rock star. This one we've got works in a bank and something else. This one we've got works in a bank. There we've got works in a bank. Okay. The other thing here is being quiet, being honest, and so forth. But if you look through these, this one has works in a bank and something else. So this is less likely than working in a bank. This has been a rock star, this is honest, and so this one is also less likely than working in a bank. So if we're looking for the most likely thing, these make them less likely. So let's just sort of ignore that part. That makes it less likely. It's already more likely that she works in a bank. This one there's nothing to be more. This one she works in a bank. So we've got either working in a bank, this is more likely than it was originally. So I'm making things more likely. Here I've got Alice being a rock star. In this one, either she's a rock star or she works in a bank. So this is the most general one. This is more likely. Because there are 2 chances here, either working in a bank or being a rock star. Here there's just one of them, here's just one of them, here's one of them, and here's one of them. Okay, so the most likely one is this one, because of disjunction. There are 2 ways that she could satisfy this, by being a rock star and working in a bank. In each of these, there's one of them. And I've ignored the thing that makes it even less likely. So having modified that, I've made B more likely. Having modified D, I've made it more likely. So now I've just got works in a bank, rock star, works in a bank, but there's only one of them in each of that. In this one, there are two of them. So again, purely by using mathematical thinking, I've arrived at the one that's most likely. And as in number 6, it doesn't matter whether you express it in terms of probabilities or relative probabilities, however you want. Incidentally, probabilities, there are many different types of probability. There's frequentist probability, there's Bayesian probability, there's subjective probability, there's epistemic probability. Assigning numbers to the information you have and calling them probabilities is a pretty tricky thing. There are many different ways of doing it. And it's just a very complicated issue. So those of you who actually tried to use probability theory, that's fine, you can do it, but it actually gets more complicated. Not least because you end up having to talk about whether things are independent events and so forth. And the point is, you don't need any of that. Remember at the beginning I said, this course is not about rushing in and applying techniques or procedures. It's about thinking basically about the issues. And you don't need the machinery here. If you think about the issues, it comes out. Remember my exhortations? Look at a problem, ask yourself what it means, what is it saying, and try to reason in terms of the problem itself. Don't look for techniques to apply. You often need to do that, but in this case, that's not what the course is about, and many of the questions I'm giving in this course should be solved not by applying a technique, but by just thinking about the problem. And let me finish this tutorial on the problem session, and these are the only two problems I want to look at. Let me finish this tutorial session with a different problem of the same kind, where you can solve it just by thinking about the problem, not applying a technique. And here is that problem. Okay, you've arrived late at an airport, you're rushing to catch your plane. Unfortunately, your gate is at the far end of the terminal. It always seems to be at the far end of the terminal, doesn't it? The fastest you can walk is a constant speed of 4 miles per hour. For part of the way, there's a moving walkway moving at 2 miles per hour. You decide to take the walkway and continue to walk. So you're going to walk all the way, but when there's a walkway, you're going to walk on the walkway. Yes, so you can go faster, right? Just as you're about to step onto the walkway, you notice your shoelace is loose. And the last thing you want to do is get your shoelace caught in the mechanism of the walkway. So you've got a choice. You either stop and fasten your shoelace just before you step on the walkway, or you step on the walkway and then stop to fasten your shoelace whilst the walkway is moving you along. And there's no other options. Those are the two options you have. Which option will get you to the gate fastest? Now, there are two ways you could try to go about this. You could try to argue in terms of speeds and adding the speeds together and so forth. And if you do that, you're going to run into a problem. There's going to be some information that you need that you don't have. For example, I haven't told you how long the walkway is and how long you had to walk in general. So there's a problem if you try to use standard methods. However, you do have enough information to solve the problem. But if you try to apply relative speeds, the kind of methods you were taught to use in the high school for solving problems about speeds, relative speeds and so forth, you're going to run into problems. And you don't need that. If you think about the problem, you should be able to solve it. Well, I'm just going to leave you with that one. It's an interesting problem. I think it's a rather neat problem. There are many problems like this that you really can just solve by mathematical thinking. And the point is, this again is all about this important notion, mathematical thinking. It's powerful. If you can master mathematical thinking, many problems can be resolved without going into the complexity of applying mathematical techniques. Mathematical techniques are what you need when mathematical thinking alone doesn't work. But often you can get by with just mathematical thinking. So good luck on that one, and enjoy it. It's a lot of fun.